Section: Introduction. In this section, we introduce a new benchmark called Ruler to assess the capabilities of language models in handling long context scenarios. Ruler consists of 4 task categories that go beyond simple retrieval from context. These categories include retrieval, multi-hop tracing, aggregation, and question answering. When compared to existing benchmarks, Ruler stands out as it solely focuses on synthetic tasks, allowing for better control over sequence length and task complexity. By using synthetic input, Ruler reduces the reliance on prior knowledge, which can sometimes hinder the performance of models when dealing with long context inputs in real-world tasks. We evaluated 10 different long context language models using Ruler, ranging from context lengths of 4K to 128K tokens. Despite achieving high scores on basic tasks like the needle-in-a-haystack test, all models showed a significant drop in performance as the complexity of tasks and sequence length increased. Only 4 models were able to effectively handle a sequence length of 32K tokens or more, surpassing a certain quality threshold. Among the models tested, GPT-4, Command-R, Yi-34B, and Mixtel consistently outperformed others, regardless of the weighting scheme used for evaluation. We specifically analyzed Yi-34B, which claimed a context length of 200K tokens but faced challenges in providing complete answers and accurately locating relevant information as the context size increased. Our analysis revealed 2 key trends across different models: an increased reliance on prior knowledge and a tendency to copy information from the context for tasks beyond simple retrieval. Fine-tuning on longer sequences did not always lead to improved performance on Ruler, but larger model sizes generally correlated with better handling of long context scenarios. Additionally, we found that non-transformer architectures like RWKV and Mamba still lag behind transformer models by a significant margin on Ruler. Our contributions include introducing Ruler as a benchmark for evaluating long context language models using synthetic tasks, exploring new task categories like multi-hop tracing and aggregation, evaluating various models, and making Ruler open source to encourage further research in this area. Section Summary. In this section, we introduce Ruler, a new benchmark designed to evaluate the long context modeling capabilities of language models through synthetic tasks that go beyond simple retrieval from context. Ruler consists of 4 task categories: retrieval, multi-hop tracing, aggregation, and question answering, to assess behaviors like CO reference chain resolution and summarization across varying context sizes. Our analysis of 10 long context language models using Ruler reveals that while models may claim to handle large context sizes, only a few can effectively perform at higher sequence lengths, with larger model sizes correlating positively with better long context capabilities. Section: The Ruler Benchmark. In this section, we present the Ruler benchmark, which includes tasks in 4 categories: retrieval, multi-hop tracing, aggregation, and question answering. The retrieval tasks involve finding specific information in a large amount of text, similar to recalling information based on a given cue. We have developed different versions of the needle-in-a-haystack (NEA) test to evaluate models based on their ability to find information accurately, ignore irrelevant details, and retrieve multiple items when needed. In the multi-hop tracing task, we focus on tracking variables mentioned in a text and identifying references to the same entity throughout the text. This task helps in understanding how information is connected and referred to in a long passage. The aggregation tasks, common words extraction, CWE, and frequent words extraction, FWE, require summarizing relevant information from a text by identifying common or frequent words. The complexity of these tasks can be adjusted by changing the number of common words or the distribution of word frequencies. Lastly, in the question answering category, we simulate answering questions based on long passages by including relevant paragraphs containing answers, among other distracting information. This setup mirrors real-world scenarios where questions need to be answered by extracting information from a large amount of text. Section Summary. In this section, we introduce the Ruler benchmark, which encompasses tasks in retrieval, multi-hop tracing, aggregation, and question answering. The retrieval tasks include needle-in-a-haystack tests with variations like single NIA, multi-keys NIA, multi-values NIA, and multi-queries NIA to evaluate models based on criteria like agnosticism, handling hard distractors, and high recall. The multi-hop tracing task involves variable tracking to identify co-referencing entities in a chain throughout a long context, while the aggregation tasks, common words extraction and frequent words extraction, focus on summarization by extracting relevant information from input sequences. Lastly, the question answering tasks involve inserting golden paragraphs into randomly sampled paragraphs to simulate long context QA scenarios. Section: Models and Inference Setup. In this section, we selected 10 long context language models, LLMs, to evaluate their performance. These models varied in size and context length, including both open source models and a closed source model, GPT-4. We used a system called VLLM for evaluation, running the models on NVIDIA A100 GPUs with bfloat16 and greedy decoding. We tested these models on 13 tasks with different complexities from the ruler categories. The task configurations were chosen based on a correlational study described in the appendix. Each model was evaluated on 500 examples for various lengths, following each model-specific chat template. We observed a decrease in performance as the input length increased in the ruler tasks. To determine the maximum effective context size for each model, we set a performance threshold based on the Llama 2-7B model at a 4K context length. We compared models using a weighted average score across different context sizes. The results showed that none of the models maintained performance above the Llama 2-7B baseline at their claimed context length, except for Mixtel, which performed moderately well at double the claimed context size. Despite some models excelling in specific tasks like passkey retrieval, most showed significant performance degradation as the sequence length increased. The best performing model on Ruler was GPT-4, with the least degradation when extending the context size. The top 3 open source models, Command R, Yi34B, and Mixtel, used a large base frequency in rope and had more parameters. The LWM model, despite being trained with a 1M context size, performed worse than Llama 2-7B at 4K but showed less degradation with longer context sizes. We also analyzed the error patterns of the Yi34B200K model on more complex tasks. The model struggled with certain types of inputs, such as word number pairs, and had difficulty ignoring distractors in the context, leading to performance drops in specific scenarios. Section Summary. In this section, we evaluate 10 long context language models, LLMs, using VLLM, running inference on 8 NVIDIA A100 GPUs with bfloat16 and greedy decoding. We rank these models based on effective context size, weighted average scores, and performance on various tasks, highlighting discrepancies between claimed and actual performance, with GPT-4 showing the best performance at shorter lengths. Additionally, we analyze the non-robustness of Yi34B200K model to different task configurations, such as struggling with needle types and failing to ignore distractors, impacting its performance on complex tasks. Section: Return incomplete information. In this section, we observed a significant drop in performance when our model had to retrieve multiple items from a long input, as seen in previous works. For example, increasing the number of queries from 1 to 8 led to a decrease in performance by around 15 points. When the model needed to retrieve multiple values associated with the same key, it often gave duplicated answers without providing the complete set of values, indicating uneven associations between the key and its values. We also noticed that our model had a strong tendency to directly copy from the context when the input length was scaled up. This copying behavior was most prominent in tasks involving variable tracking and common words extraction, where over 80% of the model's output in the extraction task was simply copied from the example provided. This behavior was also observed in other models but to a lesser extent. This highlights the importance of testing behaviors beyond simple retrieval when dealing with long input contexts. Furthermore, in tasks involving variable tracking, increasing the number of chains and hops led to a significant decrease in our model's performance. Errors were made due to returning empty strings or variables from incorrect chains, indicating a lack of ability to accurately trace entities within long contexts. These errors were also present in models that did not exhibit the copying behavior. In aggregation tasks, we identified two common failure modes: incorrect use of contextual information and inaccurate aggregation. Some models ignored contextual information and relied on pre-learned knowledge to answer queries, leading to incorrect outputs. Additionally, in long context question answering tasks, our model showed frequent hallucinations and reduced reliance on context, resulting in performance similar to a no-context baseline. We also explored the impact of training context length and model size on performance. Larger context sizes generally led to better performance, but the improvement was inconsistent for longer sequences. Models trained with larger context sizes sometimes struggled to adjust to new contexts, leading to performance drops. Additionally, larger models outperform smaller ones, highlighting the benefits of scaling model sizes for improved long context modeling. Section Summary. In this section, we observe significant performance degradation in our model when retrieving multiple items from a long input, with a notable drop in performance when increasing the number of queries. Our model tends to copy verbatim from the context when scaling the input length, leading to errors in tracking entities within long contexts and unreliable aggregation in tasks. Additionally, in QA tasks, we notice frequent hallucinations and reduced reliance on contextual information as the context size increases, impacting the model's performance. Section: Effect of Architecture. In this section, we examine the impact of architecture on model performance. We assess the effective context length of two models, RWKV-V5 and MAMBA 2.8B Slim PJ, which do not use transformer architectures. Our analysis reveals that both models experience significant performance decline when the context size is increased to 8K. Additionally, they consistently perform worse than the transformer baseline model, Llama 2-7B, especially when the context length is below 4K. However, beyond 4K, Llama 2's performance in extrapolating context length diminishes.